helicopter will prove that the engine can be operated in this way, and the helicopter can be also operated only with one of the two engines operating in these conditions during a limited amount of time. And this is very special for helicopter engines. This is what is called one engine inoperative rating, so a much higher rating than the nominal one, than the maximum one, when all engines are operating, but used during a very short amount of time. How much? It depends. It depends on the mission. If you are always flying above ground, maybe you will take 1 minute or 30 seconds. If you have an helicopter that is flying over the sea, it cannot land on the sea. And maybe then you will take 15 minutes, 30 minutes, it depends. If you are just going 1 or 2 or 3 kilometers in the sea, it cannot be needed to have 30 minutes. But if you are going far away, then you would have a 30-minute, it's quite possible that to have a 30-minute OEI. Of course, a 30-minute OEI will not be 135%. It may be 120% or 115%. But this is the philosophy behind this certification of helicopter engines. Very specific for helicopter engines. If you have helicopters with 3 engines, then it's still one engine inoperative, and the 2 other engines are switching to the OEI mode for 2 engines instead of 3 engines, and of course this value will be lower. So, of course. The other feature that we need to discuss about helicopter engine, it is much more difficult. This is certainly one of the most difficult concepts to understand for this course. And that will be applicable for helicopter engines, and that will be also applicable for aircraft engines. This is what we call the problem of the flat rating. Flat rating. What is that exactly? We have explained that the power available is a function of the outside air temperature. It was explained during the previous hour. And what I have explained is that the OAT has a negative impact on the available power. This is a curve, let's say, like this. This curve, I have explained, is also a function of the TIT. That means I have different curves, like this one, for different values of the TIT increasing in this direction, with certainly the curve of the TIT max that is somewhere existing. What does that mean? What does that mean? The pilot is selecting the operating regime, the rating of the engine, and is, for example, pushing the engine to its maximum, let's say. So operating the engine on TIT max. And he is, let's say, in the summer. And he is flying very long flight, very long flight. And he's taking off at 6 o'clock in the evening, and it's warm. And then he's moving, let's say, north, and he's flying during hours and hours. So flying at 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock. And the temperature is decreasing. Temperature is decreasing. What's happening? The pilot is here, for example, at the beginning. So high outside air temperature. And what's happening with the decrease of the temperature, not changing the TIT, the power is increasing. The power delivered to the gearbox, the power delivered to the rotors. So this is this power that is increasing. What's happening if the power there is increasing? You can face two problems. You can face that you could break the shaft because there are 3 limits on a shaft, and one of them is the transmitted torque that could break the shaft. And the second one is the limit of the gears that you have here inside. You could also break by bending the gears, the gear teeth that you have here inside. And so at a certain moment, by reducing the OAT, the power here and there is increasing, and you could break the shaft or break one of the teeth. And what is then the solution? You could say, I will increase the diameter of the shaft so that it is not taking place. I will use heavier teeth, other material, larger thickness of the teeth, I don't know. So to avoid the situation, to avoid the danger. But then the engine will become heavier. And this is something that you cannot afford. So what will be the situation? We will say we cannot go higher than a certain limit of the power. We will limit, flat rate the power. So we will not afford the system to go to a power higher than this one for any circumstance that could take place. And how will we do that? You see that depending on at which TIT you are working, it depends if you are at this TIT or another TIT, what will you do? You will define from a certain temperature, this is a certain OAT, that we call the flat rating temperature. You will say, you cannot follow anymore the curve there, you need to go this direction. How can you do that? You see that you will reduce the TIT. If you are there at the TIT max, you will reduce the TIT. If you are there not at the TIT max, you will also reduce the TIT. So, in order to follow this curve, in fact, along this curve, in fact, the TIT is reduced. So what is in fact reduced? This is the fuel-to-air ratio. Because the TIT is proportional to the fuel-to-air ratio. I have not said that you are reducing the fuel flow, because when you move into this direction, OAT is changing, the mass flow rate of air is changing. And so TIT is changing, fuel-to-air ratio is changing. I have not said that the fuel flow is changing. I have not said that. I have just spoken about the fuel-to-air ratio. And this is what is called the flat rating. If you do not do that, you would need to have a larger diameter for the shaft, or you would need to have larger teeth in the gearbox, and the system would become heavier. You can do it, but you have to fix a limit at a certain moment. Of course, this limit will also depend on the time spent in this situation. So if you want to allow, if this is, for example, continuous operation, if you want to fix the OEI 5 minutes here, this is certainly possible, because you decrease the time at which you will operate, during which you will operate, so you will have also different flat rating limit, depending on how long you are staying at that situation. That's why I've discussed the OEI before discussing the flat rating. And this is a very strange situation, huh? Because, so this is what we call, in fact, here, this is what we call the thermal limit of the engine. And this one, the yellow one here, is what we call the mechanical limit of the engine. And you see that the engine has indeed now two different limits. One, let's say, on the right-hand side, that is due to the thermal effects. This is related with the TIT max. And on the left-hand side, this is related with the mechanical limit with the gearbox and or the shaft of the engine. And that's why you use this term turbo shaft. This is an engine that is characterized mainly by its shaft and what the shaft is doing and by the limit that you have on the shaft. And in order to explain you what's happening, I want to discuss before ending today, so what's happening related to this flat rating temperature. Let's imagine that you are in an helicopter and you are the pilot. Or are you taking off in an helicopter? You are pulling on the collective pitch, on the collective stick, so that the blades are getting a higher angle of attack. When you increase the position of the collective lever, what's happening? You are raising the blades, and the power you need to drive these blades at a constant rotation speed is increasing, increasing, increasing. And so what do you see? In front of you, you have an indication related to the TIT. It will be more the EGT, which is the temperature here, the EGT, the exhaust gas temperature. So this is TT4, not TT3. And you will see the EGT rising, so going up. And you have also an indication of the torque. So not of the power, but of the torque that you have here. And you will see also, because the power is increasing, rotational speed is constant, you will see the torque increasing. If you take off, let's say, with just the pilot, you will take off, you will not have reached any of the EGT limit and any of the torque limit. Then you land and you take 3 other persons, you do the same, you take off, and you will take off with an EGT limit that is higher and a torque limit that is higher. Not a problem. You land, you take other 2 persons, and what's happening at that time? If you are in the summer, you are on the right-hand side of the flat rating temperature. And when trying to take off with these